All right, homework day 24. Solving systems of equations. System of equations is when you have more than one variable, and when you have a system of equations, the number of variables you have corresponds to the number of equations you have to have. So if you have two variables, you have to have two equations. If we would have three variables, we'd have to have three equations, and so forth and so on. We're just going to do ones with two variables. There's a whole lot of ways to solve system of equations. If you get to college algebra, we'll probably solve it 5 different ways. But in introductory algebra, we're just going to do it 2 different ways. One way is solving by substitution. If one of your equations is solved for x or for y, or it's easy to solve it for x or y, we can solve by substitution. What we're going to do is replace the y in our other equation with what y is equal to. In this case, y is equal to 2x plus 4. So in place of that y down there, we're going to put parentheses, and we're going to put the 2x plus 4 in its spot. So rewriting the second equation, we're going to have 5x minus 2, and then in parentheses, where the y was, we're going to put the 2x plus 4. And then we're going to have equals the negative 9. Now we have an equation that just has one variable. Looks like those big long ones that we solved in chapter 1. And so we have to first of all get rid of the parentheses. So 5x, negative 2 times 2x would be minus 4x. Negative 2 times 4 would be minus 8, equals our negative 9. Next thing we did was combine our like terms. 5x minus 4x was x. X minus 8 equals negative 9 then. And then in order to solve that for x, we've got to move our 8 to the other side. So we're going to add our 8. X equals negative 1. So there's going to be a box that says x equals and y equals. We know that x equals negative 1. We still need to find what the y value is. So what we're going to do is go back to this first equation that said y is equal to 2x plus 4. But now we know what x is, so we can put the negative 1 in for the x. So 2 times negative 1 plus 4. 2 times negative 1 is negative 2. A negative 2 plus a 4 is a positive 2. Y equals 2. Now if we really weren't sure if we did it right or not, we could check our answer by using this second equation and putting in the x and the y value. If I take 5 times the x value of negative 1 minus 2 times the y value of 2, do I get negative 9 for an answer? Well, 5 times negative 1 is negative 5. Negative 2 times 2 is minus 4. Sure enough, I do get negative 9, so yep, it checks out. I know I did it right. So negative 1 and 2 are your answers. Got all that written down before I move the board. Number 2 then. Now notice this one, it has x minus 3y equals 19 and 3x plus 2y equals 2. Neither equation is solved for x or for y, but it's easy to solve that top equation to get the x by itself. If I want to get the x by itself, I'm going to put the y on the other side, so I'm going to make it plus 3y. So now x equals 19 plus 3y. Now my equation's solved for x. So that means in the second equation, I'm going to replace the x with 19 plus 3y. So if I do that, what would I have?
So 3 parentheses, 19 plus 3y, parentheses, equals x.
Whoops.
Whoops. Plus 2y.
We need plus 2y equals
Equals 2.
2. There's what we should have. So we just replaced the x in that bottom equation with the 19 plus 3y, and everything else just came down. In order to solve that, we have to start by using our distributive property. So 3 times 19 first. 57. 3 times 3y
9y.
plus 9y. And then we're going to bring down the plus 2y equals 2. That wasn't in the parentheses. Next thing we want to do,
57 plus 11y.
57 plus 11y equals 2 because we combined our like terms. Then we're going to subtract the 57 to get the y by itself. So minus the 57, 11y would equal negative 55, right? And then divide by 11. Y equals negative 5. By the way, if that's not coming out to a nice integer, a nice whole number, we know something's wrong because you're not going to get any fraction answers. So we found the y was equal to negative 5. We want to now find what the x is equal to. What equation should we probably use to find out what x is equal to? This top one that we rearranged because we solved that for x, right? We said that x was equal to 19 plus 3y, but now we know that y is a minus 5, right?
Yep. So we're going 19 plus 3 times negative 5.
And then if we simplify that,
Minus
19 minus 15 is 4. So if we just check it quick in our head, 3 times 4 is 12. 2 times negative 5 is minus 10. 12 minus 10 is 2. Yep, my answer checks out. So, not short problems. So number 3, we have 5x plus 4y equals 3 and 3y minus 7 equals x. So we do have that bottom equation solved for x. They just wrote it backwards to see if they could mess you up. Since this one is solved for x, we can use our top equation and replace the x with the 3y minus 7. So if we do that, what would we have?
3y minus 7 parentheses plus 4y equals 3. Okay.
Getting rid of our parentheses, we then would have
15y minus 35 plus 4y.
So 15y minus 35 plus 4y equals 3. Then we're going to
19y minus 35.
combine our like terms. So 19y minus 35 equals 3. Then we would
Subtract 30, no, add 35.
add 35. 19y equals 38.
Divide by 19.
And divide by 19. So
Right, 2.
y equals 2. We found y. We need to find x. How are we going to find x? Substitute that into our second equation. 3y minus 7 equals x, and we know that y is going to be 2, right?
3 times 6 minus 7 equals 1.
Equals what?
Negative 1.
Negative 1. And so we say, okay, 5 times negative 1 would be negative 5. 4 times 2 would be 8. Negative 5 plus 8 is 3. Yep, checks out. We did it right. Always good to check your answer just in case you got positive 1 instead of negative 1, right? Now, Sometimes we have a system of equations that don't have a plain x or a plain y, and if we tried to rearrange it and solve it, we'd have a bunch of ugly, nasty fractions to work with. Not that you couldn't do that, but it's a lot harder to work with fractions. So this method is called the elimination method. What you're going to do is you're going to multiply either one or both equations times something so you get opposites, either in front of your x or in front of your y, so that when you add the two equations together, you can cancel out one of your variables. So you look in front of the x's and say, okay, what is my least common multiple of 6 and negative 3?
3.
Multiple.
Oh.
6 would be, right? So if I wanted to make these opposites, since this one's already 6, I would multiply the bottom equation by 2. Because if I multiply the bottom equation by 2, I'm going to get a negative 6. So one will be 6, one will be negative 6, and they'll be opposites of each other. Now when I multiply, I have to do the whole equation. So the top equation is going to stay the same. 6x minus 5y equals 18. The bottom equation would be negative 6x. 2 times 4 would be plus 8y equals 2 times negative 18, so negative 36. Now what I'm going to do is add my equations together. When I take 6x minus 6x, it's going to cancel out, right? I get 0. Negative 5 plus 8 would be 3y. 18 minus 36 would be negative 18. In order to solve that, all I'm going to do is divide. Y is going to equal negative 6 then. Now, in order to find x, I don't have an equation that just says x equals something. What I have to do is just pick either one of those two equations and substitute the negative 6 in for the y. Does it look easier to use the top one or the bottom one? Top one? Okay, so I'm going to use the top one. The top one says 6x minus 5y equals 18, but I know that y is negative 6. So if I simplify that, negative 5 times negative 6, positive 30. So I have 6x plus 30 equals 18. If I'm going to solve that, I've got to move my 30 to the other side. So I'm going to minus my 30. 6x then would equal negative 12. And then, of course, I have to divide by 6. So x equals negative 2. And again, if I wanted to double check and make sure my answer was right, I'd check it in my other equation. Negative 3 times negative 2 would be 6. 4 times negative 6 is a negative 24. 6 minus 24 is negative 18. Yep, it checks. So those are my answers. So in this one, we only had to multiply one equation times something to make opposites. Sometimes you have to do both. Got this one all written down. So number 5 wants us to solve the system of equations. We have negative 3x minus 8y equals 6 and negative 5x minus 6y equals 10. If I want to eliminate my x's, I want my least common multiple of 3 and 5, which would be 15, right? So one of them we want to be positive 15, the other one we want to have negative 15. So we think about, well, what can I take times my top equation in order to get a positive 15? We can multiply that by a negative 5. Since I made the top equation positive 15, means I want to make my bottom equation negative 15. So I think about, well, what do I take times negative 5 to get negative 15? I'd have to have a positive 3. I'm then going to multiply that whole top equation by negative 5. Negative 5 times negative 3x would be 15x. Negative 5 times negative 8y is positive 40y. Negative 5 times 6 is minus 30. On my bottom equation, multiplying everything times 3. 3 times negative 5x would be negative 15x. 3 times negative 6y is negative 18y. And 3 times 10 is 30. So if I add my equations together, my x's are opposites. I've got a positive 15 and a negative 15. Those are going to cancel out. 40 minus 18 gave me 22y. And negative 30 plus 30 is 0. So if I take 0 and I divide it by 22, we still get 0, right? It's okay to have an answer of 0. Y can equal 0. So if I get an answer of y equals 0, I still need to go back and find my x. I can put it in either equation. Which one looks easier to use? Top or the bottom one? The bottom one? Okay, we'll put it in the bottom one. Negative 5x minus 6y equals 10. If y is 0, what happens when you do negative 6 times 0?
0.
You get 0, that's basically just going to be gone then. Negative 5x equals 10. And then in order to solve that, we would divide by negative 5. So x is going to equal negative 2. If I want to check that, since I used the bottom one over there, I need to use my top one. Negative 3 times negative 2 is a positive 6. Negative 8 times 0 is 0. 6 plus 0 is still 6. So those should be my answers. So I'm thinking, she just typed it in. So looking at number 6, if I look at getting rid of the x's or getting rid of the y's, what would you rather do?
We'll do the x.
Do the x. So if I'm thinking about my least common multiple of 9 and 3,
9.
it'd be 9. That means I don't need to take the top times anything because it's already negative 9. Negative 9x minus 7y equals 1. But what should I take the bottom equation by? Negative 3. Why do I want to use negative 3? Because I want to get a positive 9. Negative 3 times negative 3x would be 9x. Negative 3 times a negative 2y would be positive 6y. And negative 3 times a negative 1, positive 3. So if I add those two equations together, I'm going to get negative 1y equals 4. And when I divide then, y equals negative 4. So once I find y, I have to go back and find x. Which equation looks easier to use, the top one or the bottom one? Bottom one looks easier to me too, the numbers aren't as big. So we have negative 3x minus 2y equals negative 1. We know that y is equal to negative 4. So if we multiply that out, we would get negative 3x plus 8 equals negative 1. If we're going to solve that, we would then minus 8. So negative 3x equals negative 9 then. And then we're going to divide. X equals 3. So just quickly checking that. Negative 9 times 3 would be negative 27. Negative 7 times negative 4 is a positive 28. Sure enough, negative 27 plus 28 is 1. So it checks out. We know we did it right. The next ones. Oh man, this is too big to fit on the screen. Well, I'll just cut the picture off of it. I'll read it first and then I'll move it up. Pablo will rent a car for a day. The rental company offers two pricing options, option A and option B. For each pricing option, cost in dollars depends on miles driven as shown below. So just looking at our graph and using some common sense here, miles driven, cost in dollars. If I drive 0 miles, option A is going to cost me $30, and then it's going to increase as I drive. If I drive 0 miles, option B costs me $60, but option B is just going to cost me $60 all the way across, right? Doesn't matter how many miles I drive. So it says, if Pablo drives a rental car for 75 miles, which option is going to cost me more? Well, 75 miles isn't specifically marked, but where is 75 miles? It's going to be halfway between the 60 and the 90, right?
Yeah.
So at 75 miles, if I look here, how much does option A cost me? $45, right? If I go up to option B, how much is option B going to cost me? $60. Which one cost me more? Option B. How much more did it cost? $60 minus 45, right? $15. Or they're each going up by 5, 5, 10, 15. Now, I got to move my board a little bit so we can see the second part of that question. The second part of that question says, for what number of miles driven do the two options cost the same? Well, where do they cost the same? They cost the same right here where the two lines intersect each other. The miles are dropping down to the bottom, so how many miles is that? 150 miles, right? 150 miles. If Pablo drives less than this amount, meaning less than the 150, you can pick anything less than the 150. Maybe you want to go to 60. Doesn't matter. If he drives less than this amount, which one is going to cost me less? Anywhere less than this, which line do I run into first? Option A. So, checking to see if you know how to read a graph and all of that good stuff. Sam can choose Plan A or Plan B for his long distance charges. For each plan, the cost in dollars depends on the minutes used per month as shown below. So, option A starts out, if I don't make any phone calls, I don't have to pay any money, and my price increases as I goes along. Option B, I have to pay $10 just to have my phone, whether I talk on the phone or not, for the first 80 minutes. Then after that, it starts going up if I talk more than 80 minutes. So it says if Sam makes 200 minutes of long distance calls, 200 minutes, which plan is going to cost me less? Plan B is going to cost me less, because that's the one I run into first, right? But then I have to know how much less. So if I look, for 200 minutes, how much did Plan B cost me? $16. How much would have Plan A cost me? $20. So how much more did it, or how much less did it cost?
$4.
$4 less. $4 less. 20 minus 16, $4. Now to see the second part of that, but I still need the graph. For what number of long distance minutes do the two plans cost the same? 120. Right here's where they intersect. If I go straight down to the number of minutes, 120 minutes. If the time spent on long distance calls is less than this amount, so use the 40 or the 80, which plan is going to cost me less? Plan A is going to cost me less. That's the first line I run into, right? Plan A. Tammy Tammy is going to rent a car for a day. The rental company offers two pricing options, option A and option B. For each pricing option, cost in dollars depends on the miles driven as shown below. So option A starts at $35 and increases from there. Option B starts at $50 and stays $50 the whole time. If Tammy drives the rental car 120 miles, which one is going to cost me more?
Our option A.
Option A is going to cost me more. So at 120 miles, option B is costing me $50. Option A is going to cost me $65, right? So how much more did it cost? $15. Second part of that. For what number of miles driven do the two options cost the same?
60.
60. They intersect here at 60. If Tammy drives less than this amount, less than 60, which option is going to cost me less? So if I pick something less than 60, option A is the one I run into first. So that's the one that's going to cost me less.